So I can tell you've been dying to look at one more reaction mechanism, right? This is an easy one. We've got some hydrogen peroxide reacting with some iodine ions, and we'll eventually see what kind of products we get. This is a fabulous reaction. We're going to do it in class. One of my favorites, actually. When I'm ready to write the overall balanced equation, we know that we're supposed to be able to cancel like terms. So if I look at these two elementary steps, eventually I know I want to add them up and cancel like terms. Here's one right away. IO negative 1. IO negative 1. It's formed in the first step, and then it's consumed in the second step. That's an intermediate. So that's B. Intermediate. IO negative 1. An intermediate is something that's formed in an early step, and then it's consumed in a later step. Now, if this were like 3 steps, it could be formed in step 1 and consumed in step 3, and that's fine. But you'll first see it on the product side, usually like in one of the early steps. And then in the later step, it's consumed, so it's canceled. That's an intermediate. You don't see it in the overall balanced equation. Alright, as I look at this reaction, I also notice something else that I could cancel. What about this goofy thing? There's iodine on both sides. You're going to see this in the reaction that we do in class. This is called a catalyst. Iodine ions. A catalyst is something that's added. So you'll first see it on the reactant side. But then in a later step, you get it back. It's recovered. We're going to talk more about catalysts in a little bit. A catalyst is something that just speeds up the reaction, but it's not part of the overall balanced equation. It's not part of the stoichiometry. It's not part of the reactants or the products. You should be able to collect your catalyst and reuse it again. It is not changed in any way. So the difference between the two, the catalyst is something that will first appear as a reactant. It's something that's being added, and then later on you get it back on the product side. An intermediate is the opposite. An intermediate will first be seen as a product, but then in a later step it's consumed. So then we should be able to write the overall balanced equation. I think that's all that we can cancel. So we're going to have 2 hydrogen peroxide that will decompose to form water and O2 oxygen gas. Excellent. Now, I should mention one thing here. This is a 2. And it's supposed to be a 2 in your study guide. So you might as well go ahead and put that in there. Otherwise your equation doesn't balance. But now it should. So that's just a typo in the original equation. We're totally going to do this with the help of an iodine catalyst. I mean, if you leave peroxide sitting out just uncapped, it eventually decomposes. But using a catalyst, it'll go faster. We'll noticeably see the oxygen gas bubbling from the original solution. We will not have any recollection of that intermediate, the IO minus 1. Then we'll look at another reaction that has a colored intermediate. So it's kind of wild. That when you see it turn colored, that's when the reaction's starting to go, and you see this intermediate form, but then the color goes away. It's formed and then it's consumed. So we'll kind of look at these guys in class in some demos. They're going to be awesome. The last question, piece of cake. If the concentration of hydrogen peroxide is increased, let's say it starts at 0.2 or 2.2 moles per liter, and we bring that up to 22 moles per liter, will their overall reaction rate be faster or slower? Again, kind of something that we'll mention in a little bit, but I think most of us would say faster, right? If you increase the concentration, you've got more active particles. If you have more of the active particles, there should be more collisions. And a better chance that those collisions are effective collisions. The more particles I have, the better the chance that they'll collide in the right orientation, and they'll have the right amount of energy to make this reaction occur. So, increasing the concentration does increase the reaction rate.